So chapter 11 deals with circles. We're not going to do everything in chapter 11, but there are certain things that will come back later in other classes that you just need to be familiar with. The first thing would be tangents. So what is a tangent? Well, a tangent is a line that touches the circle at exactly one point. The line is completely external to the circle, meaning the tangent, this is a tangent line. It's completely outside of the circle, but it only touches the circle at one point. Now, that one point is what's called the point of tangency. And when the radius and the tangent intersect at that point of tangency, they will always form a right angle. And so that's going to be important. Think about things that we've done with right angles. We know that with right angles, we could create a right triangle, and that would be Pythagorean theorem. You might get a 30, 60, 90, 45, 45, 90 triangle, lots of different fun things. And so we need to keep that in the back of our mind. Let's continue on. Now, let's say that you have two tangent segments that are drawn from the same point. So we have this exterior point, this point that's just outside somewhere. If you draw a tangent to the top and then draw a tangent to the bottom, those two tangent segments have to be congruent to each other. It's kind of like an ice cream cone. If you turn it upside down or turn it to the side, think about the fact that when you have an ice cream cone, those two sides have to be congruent to each other. And as we go through this, there's a lot of terms. There's a lot of like just things to know. And then we'll get into actually some of the problems. So the first one that we're going to do is using that ice cream cone type of thing. So let's look at this example here. What you're given in the black was everything that you know to be true. What you're trying to find is you're trying to find that whole length of x that's over to the left. Now notice that you have the top portion of that as 6. Based on what we just said above about the whole ice cream cone thing, every ice cream cone, every V has to have congruent segments. So what's highlighted in yellow, that's a V. So both of those would have to be 6. Now if the whole top is 11, then that means the turquoise part to the right would have to be 5. So its V, both of those parts also have to be 5. So then on the right, if the whole length is 8 and the top is 5, the bottom is 3, which means its V segment is also 3 on the bottom. So then to the left would be 4, making its matching piece also 4. So now this segment right here is 4. So 6 plus 4 gives you a whole length of 10. If we go down a little further, the next thing says, so what would happen if we, or what would happen to the angle that's formed by those two tangents when the exterior point is joined to the center of the circle? So when you take and connect this exterior point to the center and you form this red line, what happens is that it bisects this angle. And not only does it bisect this outside angle, it'll bisect the central angle at the center of the circle. Also remember the Pythagorean theorem here because those two triangles that were formed are right triangles. Not only can you have tangent lines, but circles can be tangent to each other. There's what's called externally tangent circles and internally tangent circles. Externally tangent means they would be completely on the outside of each other. So these first two, notice that they are completely outside of one another. They only touch at this one point. That's externally tangent. These next two that we have are what's called internally tangent. You have one circle that's completely inside of the other circle, but they still only touch at this one point over here. So that's internally tangent. Circles can also have common tangents. You have a common external tangent here in red. It's common because it touches both circles at one point. It's external because it's kind of on the outside of the circles. This blue tangent is a common internal tangent because it touches both circles at one point and it goes in between or on the inside of those two circles. Something else just to know is what's called concentric circles. Concentric circles are circles that have the same center. That would be like the Target sign at the store Target, or a bullseye or anything like that. Now, some of the actual problems that we're going to do, we've got this first example here. Now notice what we have. We have two circles, one of radius 9 and one of radius 4. We're trying to find the length of x, that's the tangent on the top. So here's what we're going to do. We are going to draw a line from the center of the smaller circle. So we're going to start at the circle to the right, and we're going to draw a line to intersect the radius over to the left. And what that's going to do is it's going to put a rectangle on the top and a right triangle on the bottom. So let's scroll down and see what that looks like. So we started at the center with the 4 and we drew across to the left to intersect at that 9. Now again, what we did is we created a rectangle on the top and a right triangle on the bottom. In the rectangle, the opposite sides are congruent. So if the top is x, the bottom is x. If the right is 4, the left is 4. Now if this left thing is 4 and the whole thing is 9, then 9 minus 4 is 5. I know it doesn't look right in terms of its scale, but just go with the numbers. Now this right triangle, if we knew the hypotenuse, we'd be able to use the Pythagorean theorem and find x. So think about the fact that the radius of this circle is 9, which means even right here at the bottom, this radius is 9. And if the radius over in the right circle is 4, then this radius is also 4. So since they are touching each other, 9 plus 4 equals 13. So we can set up the Pythagorean theorem to do 5 squared plus x squared equals 13 squared, or you may know that it's a 5, 12, 13 triangle, so x is equal to 12. In this next example, it's a little different because the circles are not tangent. They're not actually touching each other. But notice that they are a length of 2 apart from each other. So we have the one radius of 15, the one radius of 8. We're still going to do the same thing. We're still going to start at the small circle center, so at the 8, and you're going to draw over to the 15. So let's scroll down to see what that looks like. So as we scroll down, notice that when you draw that line over, sorry, it's a little shaky, if x is on the top, x is on the bottom, 8 is on the right, 8 is on the left, which means if this whole radius was 15, 15 minus 8 would be 7. So again, if we could find the hypotenuse here, we would be able to use the Pythagorean theorem. Well, if this radius is 15, the length between the circles is 2, and then this radius is 8, that would make the hypotenuse 25. So if we do our Pythagorean theorem, we would do 7 squared plus x squared equals 25 squared. What would you get for x? If you solve through it, you should find that x is 24. Now, as you look at some of the other examples in the book, if you look at perhaps page 586, you'll just see some examples that I've done here so that you have an idea of what's going on. What you need to do is you need to look at those problems in your book, look at my explanations here, and then see if you have any questions. Your homework is page 586, and you see the numbers that are listed there. This homework for y'all is going to be due on Monday, which is April 13th. Monday, April 13th.